Night above Earth is not empty. It's alive with things you can't normally see. Ghostly clouds shimmer high in the mesosphere, invisible plumes from rockets light up like glowing jellyfish, and the planet itself hums with mysterious rumblings no one can explain. Space, even right above Earth, is not calm. It's unpredictable, strange, and sometimes it's downright eerie. These are strange events detected high above Earth. Take a look at this. Believe it or not, that is not CGI. When a rocket launches near twilight just before sunrise or right after sunset, something strange can paint the sky that can look like a giant glowing jellyfish floating above the Earth. It's the rocket's exhaust catching sunlight way up in the atmosphere while everything below is already dark. And so the result is this huge, weird, glowing plume that can stretch across the sky. As you can see, it looks pretty nuts. Here's what's actually happening though. Once a rocket climbs up past the lower atmosphere, the air gets incredibly thin. The hot exhaust from the rocket engine, water vapor, ice, and gases expands outward like a balloon because there's almost no air pressure to hold it in. At twilight, the sun has gone down for people on the ground, but at those high altitudes, the plume is still bathed in sunlight. That sunlight catches the expanding plume and lights it up in amazing colors. Sometimes white, sometimes soft shades of blue, orange, pink. People have seen this after SpaceX Falcon 9 launches, lighting up parts of the western US. And people must have thought they were watching a UFO explode or like a ripple opening up to another dimension. Scientists have recorded mysterious low-frequency sounds high in Earth's atmosphere. These aren't thunder or airplanes or storms. They're regular repeating rumblings picked up by instruments attached to solar-powered balloons floating about 70,000 feet up. And the weird part is, they're completely unexplained. The recordings come from the stratosphere, which is normally pretty quiet and free of turbulence and jets. Infrasound sensors pick up lots of stuff like thunder, ocean waves, even distant explosions. But alongside that, researchers hear these muffled, low-frequency signals several times an hour, and they still can't identify them. These mysterious sounds show up again and again, and no one knows the source. Not volcanoes, storms, not human activity. They're literally sounds in a layer of the atmosphere where noise shouldn't be happening. We're all familiar with auroras, green or red lights dancing across the polar sky, but there's another kind of light that happens around the entire planet that's much stranger and almost always invisible to the naked eye. This is called airglow. It's a faint, continuous glow coming from the upper atmosphere that you don't notice unless the conditions are just right. Airglow is caused by atoms and molecules high above Earth, mainly oxygen and nitrogen, releasing energy as they recombine or as sunlight pushes them higher during the day. That process gives off tiny amounts of light, and while a human eye usually can't see it, from space it shows up as layers of green, yellow, red, and purple wrapping around the planet like a glowing bubble. Astronauts aboard the International Space Station can see this all the time, and there are photos of it glowing above the Earth's horizon with stars beyond it. High above the Earth, from about 90 kilometers up to hundreds of kilometers, there's a layer called the ionosphere. It's full of charged particles, electrons, and ions that can move around and form patterns. Normally, big changes in this layer happen when the sun sends out storms of charged particles that shake Earth's magnetic field. Scientists expected most strange shapes in the ionosphere to show up during these solar storms. But NASA's GOLD satellite saw something different. It spotted giant X-shaped patterns in the plasma, even when there wasn't a solar storm happening. These X-shapes are basically two long, bright ridges of charged particles crossing each other. Sometimes scientists also see C-shaped or curved patterns. They're hundreds of kilometers long and can be seen in ultraviolet light. The surprising part is that these patterns formed on, again, calm days without the sun stirring things up. So that means something else is causing the plasma to move, probably winds and waves coming from lower in the atmosphere, like storms or hurricanes far below. But these shapes matter because the ionosphere affects GPS, radio, and satellite. When it forms patterns like this, it can temporarily change how signals travel through the sky. When most people think about lightning, they picture jagged bolts flashing from clouds to ground and a big bang in the sky, but thunderstorms do something way more intense that almost nobody can see with their own eyes. And it's happening all over Earth every single day. High up over big storms, especially strong ones like tropical storms and hurricanes, the atmosphere sometimes spits out these incredibly quick bursts of gamma rays, which are the most energetic kind of light that exists. These bursts are called terrestrial gamma ray flashes, or TGFs for short. They last way less than a fraction of a second, usually only a couple thousandths of a second, and they're millions of times more energetic than the light we normally see. Satellites like NASA's Fermi Gamma Ray Space Telescope are built to detect gamma rays from deep space, but when scientists pointed it down at Earth, they found thousands of these flashes were associated with thunderstorms. In fact, there are probably hundreds of these every day around the planet. So, how do they happen? The leading idea is that inside giant storm clouds, the electric fields can get so strong that they act almost like particle accelerators. They push electrons to nearly the speed of light. And when those ultra-fast electrons crash into air molecules, the collision releases a burst of gamma rays. Above thunderstorms, lightning doesn't always just strike the ground. Sometimes it shoots upward, creating strange flashes, really strange flashes. Scientists call these transient luminous events, or TLEs, and they happen in the upper atmosphere, tens of miles above the clouds where planes can't fly. The most common type is red sprites. These are big reddish flashes that appear high above a storm and last just a few milliseconds. They often look like glowing alien jellyfish. Then there are blue jets, which shoot upward in cone shapes from the top of a thundercloud towards space. And finally, there are ELVES, which are enormous flat rings of light that spread out hundreds of kilometers across, caused by the lightning's electrical pulse hitting the bottom of the ionosphere. Astronauts on the International Space Station have taken pictures of these events. Satellites catch them all the time. They're fast, faint, almost impossible to see from the ground, but they show that thunderstorms aren't just surface weather events. They send bursts of electricity high into the sky, directly connecting the storm to space above. When a huge storm like a hurricane spins across the ocean, it doesn't just affect the weather down here either. It can send waves of air all the way up into the upper atmosphere. Scientists call these atmospheric gravity waves. They're kind of like ripples in a pond, except the pond is the sky, and the waves can reach 50 to 60 miles above Earth. NASA's Atmospheric Waves Experiment, or AWE, on the International Space Station has actually captured these waves from orbit. What they saw were bands stretching for hundreds of kilometers across, moving outward from the storm below. It's like the hurricane is slamming into the air above it, and that energy keeps traveling upward, creating a ripple effect high in the mesosphere. These waves are invisible to our eyes, but instruments that detect changes in the upper atmosphere can see them clearly. Earth has these invisible zones called the Van Allen radiation belts, which are basically giant donuts of charged particles trapped by our planet's magnetic field. Normally they hang out in pretty predictable places, but in May 2024, a huge solar storm hit. Something interesting happened. New temporary belts popped up between the usual ones. These belts didn't stick around forever. They form when charged particles from the sun get flung into the magnetosphere and find new spots to get trapped. Some of these belts had really energetic protons and electrons, more than scientists expected, and they lasted for weeks, even months in one case. Satellites that normally zip through the usual belts suddenly had to deal with extra radiation, basically unexpected hazards floating in space. You can imagine a giant invisible donut around the planet suddenly splitting into smaller donuts or layers that weren't there before. That's what it looked like in the data. Scientists study them though, because they can affect satellites, astronauts, and even the way signals travel through space. So up in space around Earth, the magnetic field isn't just some calm invisible bubble. It's more like a bunch of stretched tangled lines floating in space, guiding charged particles. Usually these lines just flow along, keeping things predictable, but sometimes they snap, and then they reconnect in a split second, shooting energy out like an invisible space lightning bolt. That's what scientists call magnetic reconnection. So imagine stretching a bunch of rubber bands, and then one suddenly breaks and snaps back, flinging pieces everywhere. It's basically what's going on. When it happens, it flings particles around at crazy speeds and heats up the plasma, basically the soup of electrons and ions floating up there. You can't see it with your eyes, but if you could, it would look like twisting, snapping ribbons of energy shooting out over thousands of kilometers. NASA's magnetospheric multi-scale mission has been watching these events, and I found them happening in spots no one expected, closer to Earth, where things should be calmer. But why do we care? Well, this is part of what affects space weather. It can mess with satellites, GPS, even radios, and on really big events, it can affect power grids on Earth. Most of the time when you look up at the sky after sunset, it's just dark. But sometimes near the poles in the summer months, people see faint wispy clouds glowing high up in the sky long after sunset. They look like these ghostly electric blue or silvery clouds that linger when everything else is dark. These are called Noctilucent Clouds, which literally means night shining. They're not the regular clouds you see during the day. They're way higher up in the atmosphere, around 76 to 85 kilometers up, almost at the boundary of space. These clouds form when tiny ice crystals gather in a part of the atmosphere called the mesosphere. That part of the sky is incredibly cold, even colder than the surface of Pluto. And if there's enough water vapor and tiny particles for ice to form around, these crystals will catch sunlight long after the sun is dipped below the horizon for someone on the ground. That's why they seem to glow at night. They're still in sunlight even when you're in shadow. They only happen in very specific conditions, very high altitude, just after sunset, and usually at higher latitudes during summer. They're subtle, they're faint, but when conditions are right, they're one of the most beautiful atmospheric phenomena on Earth. That's been the video for today. I will catch you, yes you specifically, next time.